Hi guys, welcome to AptitudeMindPlus. Today we will be discussing about time and distance concept. Okay, so time and distance. Okay, so in this concept mainly we will be dealing with formula called speed. What is speed? Speed is distance traveled over time taken or total time taken, or you can simply say d by t, distance over time. So speed s is d by t, distance by time. So this is the important formula in time and distance. So having this formula, we can derive other formulas as well. Distance formula from this one is speed into time. Okay, how did we get that? Just send this t to this side. And formula of t, time, is distance over speed. Okay, this is another formula. So if you see here, these formulas will be applied only for one object, right? So for suppose there is a vehicle moving with 10 kilometers per hour speed, okay, and time is given as 5 hours. So distance can be calculated like d is s into t. So like that, these formulas only applicable only when one item or one object is given. So what if two objects are given? Like he will be giving you two objects and he will be putting something constant. For suppose if he is saying that speed is constant, we can directly write the formula as d1 by d2 is equal to t1 by t2. We can write this formula. Okay, so how did we get that formula? See, let us derive that formula here. Okay, so remember here we have taken speed as constant here. So speed is constant, which means the speed for this vehicle and this vehicle is same. Distances are different here. So distance shall be d1 and time will be t1. And here is s is constant, distance will be d2 and time will be t2. Okay. So if you write the formula of speed, speed is distance traveled over time, right? So here distance is d1 and time is t1. So if you write the formula for speed here, distance by time, which is d2 by t2. Okay. Here speeds are equal. Okay. So then that would be d1 by t1, which equal to d2 by t2, which can be written as d1 by d2 is equal to t1 by t2. I just have rearranged these terms. Okay. So if you see here, distance is directly proportional to time when speed is constant. You should never forget this. Okay. So distance is directly proportional to t when speed is constant. So we can derive this formula, and this formula will help you when two vehicles or two objects are moving with same speed but their distances and times are different. Okay. So now we shall take distance as constant. Okay, which means distance is same in both of the cases. So here distance is same. Okay, and speed is, let us suppose it to be s1, and time is, let us suppose it to be t1, and distance is same and speed is s2. Okay, time is t2. Okay, so if you write the formula of distance here, so formula of distance is s into T. So that would be S1 into T1. Here D will be S2 into T2. Okay. So since the distances are same here, S1 will be S1 into T1 will be S2 into T2. Okay. You can remember this formula, or you can write like this: S1 by S2 is equal to T2 by T1. Okay. So if you like this one, you can remember this one, or you can remember this one. Okay. So I am writing the formulas here. S1 T1 is equal to S2 T2. Okay. This is this okay? Or S1 by S2 is equal to T2 by T1. So this is another formula. So this is when speed is constant. Okay. And this is when distance is constant. Okay. So we have seen the formulas when speed is constant and distance is constant. And you have to remember this thing. These formulas will be applicable only when speed is constant in this case and D is constant in this case. Okay. So now let us see the formulas for the formulas when time is constant. So here the time taken is same in both of the cases. So let us suppose them as T, and speeds are varying. Okay. Speed suppose it to be S1 and D is D1. And in this case, speed is S2 and D is D2. Okay. So if you write the formula for time, why do we write the formula for time? Because the time here is same in both of the cases. And in the before cases, we have written the formula for D because D is common for, D is same for both of the cases. So that is why we are writing the formulas of T here. Okay. So formula of T is distance over speed. So what is the distance here? D1. What is the speed? S1. Okay. And here for this one, what is the distance? D2. D2 by S2. Okay. So since here T and T are equal, or you can say in this way also, if A is equal to B and B equal to C, then A equal to C. You can apply that formula as well. Okay. So in that case, D1 by S1 is equal to D2 by S2. Okay. So if you rearrange these terms, you can get like D1 by D2 is equal to S1 by S2. Okay. D1 by D2 is equal to S1 by S2 when time is same for both the cases. Okay. Or time is not changing in both of the cases. So we got the formula as D1 by D2 is equal to S1 by S2 when time is constant here. Okay. So these formulas are very much important for this time and distance concept. And there is another method for this derivation of these formulas as well. So let me tell you that method also. So if you observe here, speed is directly proportional to distance and speed is inversely proportional to time. So let us suppose D is constant here. So that would imply speed is inversely proportional to T. And we have discussed about this inverse proportion, direct proportion in ratio and proportion concept. Okay. So speed is inversely proportional to T. In this case, we can directly write St is equal to constant. Or if there are two objects moving, so this formula can be rewritten as S1 T1 is equal to S2 T2. Okay. So this can be rearranged as this one, S1 by S2 is equal to T1 by T2 by sending S2 to this side and T1 to that side. Okay. And if you take T as constant, okay, here we have taken D as constant. So D constant. So if you take T as constant, S is directly proportional to D here. So S is directly proportional to D. Then that would imply S by D is equal to constant. So that would imply S1 by D1 is equal to S2 by D2, and if you rearrange these terms, you will get S1 by S2 is equal to D1 by D2. Okay, so which is this formula. Okay, so we have taken T as constant and D as constant. If you take S as constant, speed as constant, then that would be distance directly proportional to T. So how can we say that distance is directly proportional to T? So if you take T to this side, then D is directly proportional to T, or you can directly say from this formula, D is directly proportional to T. So in this case, we can write D by T is constant. So that can be written as, when this formula is involving between two objects, now we can write D1 by T1 is equal to D2 by T2. If you arrange these terms, that would be D1 by D2 is equal to T1 by T2, which is this formula. So you can follow whichever method you want. The previous method is followed by many people. If you want to follow this method, then you can follow this method as well. Okay. So now let us see the conversion between kilometer per hour to meter per second. Okay. So let me write the heading, kilometer per hour to meter per second. So generally 1 kilometer per hour, which is equal to 1 kilometer is how many meters? 1000 meters. Okay, and 1 hour is 3600 seconds. So how did I get this 3600? So 1 hour is 60 minutes, that we know. Okay, and 1 minute is 60 seconds. Okay, this 60 is this one. So 1 minute is, in the place of 1 minute, 60 seconds. Okay, so totally 6636, 2 zeros. So totally 3600 seconds will be for 1 hour. Okay, and for this conversion of kilometer to meters, so I'll give you the simple mind map for this. Okay, so let us suppose this is a meter. Okay, so from here this will be decimeter. Okay, this is centimeter and this is millimeter. So let me write this, centimeter, this is decimeter, and this is decameter, and here it will be kilometers. Okay, so you can remember this graph. So we are trying to know how many meters for kilometers. Okay, so kilometer is a higher term here. So if you count the number of stages here, see, this is one stage from here to here. So this will be second stage and this will be third stage. So 1 kilometer will be 10 power, how many stages? 3 stages, 10 power 3 meters. Okay, and this is second and this is third. So whenever you want to know how many kilometers for meters, so you want to know how many kilometers for 1 meter. Okay, so you want to know higher term in terms of lower term. So in that situation, you will be traveling in the opposite direction. Okay. So in that case, this will be 10 power minus 3, which can also be written as 1 by 1000th kilometer will be 1 meter. Okay. So if you are converting lower units to higher units, then you will be multiplying with 10. Okay. For each stage, you will be multiplying with 10. So how many meters for decameter? There will be 10 meters. How many hectometers for how many meters for hectometer? There will be 100 meters. How many meters for kilometer? There will be 1000 meters. So if you ask in the opposite direction, like how many kilometers for a meter, then that would be 1 by 1000. Okay. So try to remember this one. This is very easy. Okay. So here, if you cancel out these terms, 2 5s, 2 18s. So that will be 5 by 18 meters per second. So here we got 1 kilometer per hour will be 5 by 18 meters per second. Okay. So using this, so this is for 1 kilometer. Okay. So for 2 kilometers per hour, that will be 2 into 5 by 18 meters per second. And for 3 kilometers per hour, okay, and 3 kilometers per hour, that will be 3 into 5 by 18 meters per second. Okay. And for x kilometers per hour, okay, x kilometers per hour, that will be x into 5 by 18 meters per second. So we got the formula. So whenever you want to convert some x kilometers per hour speed into meters per second, some meters per second, then you need to remember this formula. Just multiply this x with 5 by 18, then that will be converted into meters per second. Okay. So now we have seen how to convert kilometer per hour to meters per second. And now we'll be converting meters per second to kilometers per hour. So we are converting meters per second to kilometers per hour. So we are converting lower units into higher units. Okay. So first we shall know 1 meter per second in terms of kilometer per hour. So 1 meter will be 1 by 1000th kilometer. And 1 second will be 1 by 36th hundred of hour. Okay. So we have seen this one, right? Earlier we have seen 1 kilometer is 1000 meters, right? Then 1 meter will be, send this 1000 to this side, then that would be 1 by 1000th kilometer will be 1 meter. Okay. And same for this one also. Okay. So earlier we have seen for 1 hour there are 3600 seconds. So 1 second will be 1 by 3600th part of hour. Okay. So that will be 1 second. So we have written these ones. Okay. So if you this 3600 will go up, and that will be 3600 by 1000 kilometer per hour. So if we cancel out these terms, 2 18s and 2 5s, that will be 18 by 5 kilometer per hour. So 1 meter per second is 18 by 5 kilometer per hour. So 2 kilometers per second will be 2 into 18 by 5 kilometer per hour. So likewise, x meter per second will be x into 18 by 5 kilometer per hour. Okay, so this is the formula for converting x meter per seconds to kilometer per hour. You just need to multiply this x with 18 by 5, then that will be converted from meter per second to kilometer per hour. So earlier we have seen the formula for x kilometer per hour. So the formula is, you just need to multiply this x with 5 by 18 in order to convert this into a meter per second. Okay, so both the formulas are listed over here. So if you want to convert this x meters per second to kilometers per hour, then this x should be multiplied with 18 by 5. And if you want to convert the x kilometer per hour into meter per second, then you just need to multiply with 5 by 18. Okay, so for just remembrance, I'll tell you the trick. So here we are converting lower units to higher units. We want higher units, so that is why 18 is the bigger one when compared to 5. So we shall be multiplying with 18 by 5. And here we are converting from higher terms to lower terms. So here we need lower terms, right? So out of 18 and 5 is the lower term. So we will be multiplying with 5 by 18. So you have to remember one thing, we have only two numbers, 18 by 5, 5 by 18. Okay, only these two numbers we got here. So 18 by 5 for meter per second to kilometer per hour conversion, because we want higher units. So higher units, that is why this one. So this one is small, that means we are converting into smaller units. So kilometer per hour into meters per second. So this one is for this one. Okay, so you can remember these formulas like this, or you can find your own method to remember. Okay, so this is a summary of time and distance concept.